Hello everyone. In today's lesson, we're going to be talking about the binomial distribution. So first we're just going to be looking at probability distribution as a whole. So first, for some vocabulary, random variable is a variable whose value is determined by the outcomes of a probability experiment. So for example, rolling a six-sided die, the random variable x represents the number showing on the die. So that means that the possible values of x in this case would be 1, 2, 3, 4, 5, and 6. So that's the random variable. A probability distribution, on the other hand, is a function that gives the probability of each possible value of a random variable. And some facts with this is that the sum of all the probabilities in a probability distribution must equal 1. So when we're creating these probability distributions, one way that you can check your work is to see, okay, if I add up all of my probabilities, that should equal 1. So for example, the probability distribution for rolling a six-sided die, x, my random variable, is the outcome, so I can roll any of the numbers between 1 and 6. And my probability for each number, if I'm just rolling a standard six-sided die, it's going to be a 1 out of 6 chance. So to roll 1, I have a 1/6 chance of rolling that. And I notice if I add up all of this row, so if I add up all of the p of x, the sum is 1. So let's look at an example of constructing a probability distribution. So we're going to let x be a random variable that represents the sum when two six-sided die are rolled. Make a table showing the probability distribution for x. So x here is going to be the sum that is our random variable here. And we're looking at rolling two six-sided die. So I want to see, okay, what are my different sums I can have? And how many of each of those sums can I have for an outcome? So I'm going to go ahead and just write down all of the different sums I can have. So, or the possibilities you can roll. So I'm rolling two six-sided die. Let's say the first roll is a 1. Then my second roll could be a 1. My second roll could be a 2, 3, 4, 5, 6. My first roll can be a 2. All right, and then I can have 1, 2, 3, 4, 5, 6, and just continue in that pattern. So my first roll can be a 3, and then I can roll the numbers 1 through 6 there. My first roll can be a 4. My first roll can be a 5. And then lastly, my first roll could be a 6. So let's look at the different sums I can have. And so I'm just going to go ahead and write a different table over here looking at all the sums. So if I add 1 and 1, I get 2. 1 plus 2 is 3, 4, 5, 6, 7. So that comes to that first column. The next column, 2 plus 1, I get 3. 2 plus 2, I get 4, 5, 6, 7, 8. Next column, 3 plus 1, I get 4, and 5, 6, 7, 8, 9. And following that, I have 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, and 12. So those are just the sums of my rolls that I see on the left-hand side. So now I'm going to fill in this table. So the different sums I have 2 all the way until 12. So I have my possible outcomes here are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then I want to count how many I have for each sum, because that's going to help me create that probability. So for my outcomes here, I have 1, 2, 2 3s, 1, 2, 3 4s, 4 5s, and then 5 6s. For 7s at 1, 2, 3, 4, 5, 6 7s. 8s I have 1, 2, 3, 4, 5. 4 9s, 3 10s, 2 11s, and 1 12. And then I'm going to find the probability of each x. So the probability for rolling a 2 or getting a sum of 2, I say there's one outcome out of 36 total outcomes. So that means it's going to be a 1 out of 36. Next one, I have 2 outcomes of rolling a 3. So that's 2 out of 36, which is the same as 1 out of 18. Next one is 3 out of 36, which is equivalent to 1/12. 4 out of 36, which is equivalent to 1/9. 5 out of 36. 6 out of 36, which is equivalent to 1/6. And then I repeat everything from before. So 5 out of 36, 1/9, 1/12, 1/18, and 1/36.